Thanks everybody for tuning in. I wanted to first give a shout out to everybody who took part in organizing, is emceeing, is speaking. I think it's really awesome that we're able to, even in these uncertain times, get together, create a community, and go over a lot of amazing content together. And so with that being said, I'll be chatting today with all of y'all about debugging networking failures. So to get started, I wanted to do a quick introduction. Hello, my name's Angela. I'm a software engineer at VMware. I'm based in Los Angeles, California, although right now in this time of social distancing, I guess that doesn't matter quite so much. And I work primarily on networking solutions for our platforms. I was previously at Pivotal, where I worked on networking for Cloud Foundry and Kubernetes, and I'm continuing to do so as part of our Tanzu portfolio now. I always like to end the introduction with a fun fact, and so in case you couldn't tell from the picture, love good food, and I want to take this time also to plug going to support your local restaurants and businesses by ordering takeout or delivery. Like maybe tomorrow night, it's a Friday, you made it through another week, treat yourself and go get some great food. A lot of amazing restaurants that normally don't offer delivery or takeout currently are. So it's really a win for you while also feeling good about supporting your local economy. And so with that, I'll get off my soapbox and we'll start actually talking about debugging networking problems. So I wanted to start by acknowledging that networking is a pretty large space. It's a broad domain. From layer 2 to layer 7, it covers a lot of ground, which means that when things go wrong, it can be hard to know where to start debugging. This is further compounded by the fact that your network setup is infrastructure and platform specific. So what I'm using in my home lab is probably different than the networking or infrastructure you have set up at your company or organization. And so this makes it really hard to say that there's one definitive way to debug networking solutions, because it really can be platform and infrastructure specific. What you have access to, what networking stack you're using, it's really hard to generalize. And so I wanted to start by acknowledging that and say that for the rest of our time together, while we're trying to be as generic as possible so that you can have some takeaways to apply to debugging networking problems in your own environment, we won't be able to cover every case. And furthermore, because we're trying to be general and have an explanation of tools that the majority of folks should be able to utilize, that means we aren't going to be going deep into any one technology, any one platform, any one infrastructure, load balancer solution, et cetera, et cetera. So what we will cover today, though, is we're going to start by doing an initial framework for debugging. Of course, we're talking about debugging networking solutions, but by talking about how we can really approach debugging in a thoughtful fashion, we're really going to set the ground for hopefully being able to take this and apply it not only to networking problems, but debugging any technical issues. We'll then move from, once we sort of level set on that initial framework for debugging, specifics for networking by looking at some helpful tools that you can pull from your toolkit. And lastly, we'll explore quote unquote common networking scenarios that you might face in terms of bugs or gotchas or problems, and sort of think at a high level about how we can apply the framework and utilize the tools to get to the root cause of a networking issue. And so with that, we'll start with a framework for debugging. I always like to start at a really high level when talking about debugging because I think it's really important to have the right mindset and approach. When a problem arises, um, it's not a great feeling. You want things to work the first time. If you're running into a problem and you need to debug that you're working on locally, that can be a minor annoyance. If a problem is arising that's impacting a production system or your customers, then that minor annoyance can turn into full-blown panic. And I think it's important to acknowledge that panicking or being annoyed is a really logical reaction. And I'm not here to tell you that you shouldn't be panicking or you shouldn't worry, but rather we should be taking that initial panic or concern and redirect that energy into actively looking for a solution to the problem. And so I wanted to start with some general best debugging practices that you should be applying when we're trying to get to the root cause of an issue. And this isn't just specific to networking, but applies to any debugging scenario. The first thing that I always like to recommend is to create a playbook. Um, More often than not, we don't really think about creating a playbook until we've had to debug a really hard problem. But by coming up with a set of steps ahead of time, even a playbook that's just saying, this is a framework of who you should involve or where you should document things, this will not only help future you, but it's also going to help other team members keep their cool when problems arise in the future. And also by having a playbook that's shared amongst you and other members of your team, you also then have that shared working agreement on how you're going to tackle a problem. Now, as part of your playbook, the second tip I have is that hopefully your playbook incorporates using the scientific method. I know that when somebody first mentioned using the scientific method in debugging, it really took me back to, grade school and science fairs where the scientific method was always harked upon us. But there's a reason that it is, because by utilizing the scientific method, you can really go both broad and deep into finding that root cause. You can get the breadth by gathering evidence, and then by being able to make hypotheses that can be validated or invalidated, you're able to get that depth of looking into different possible root causes, whereas at the same time, you can have the benefit of being able to pull yourself back up once you've proven that a hypothesis isn't true. So you're not going to go too far down any one rabbit hole. And then last but not least, a general tip I have, and the most important one, is really to ensure that information is being collected and shared from a central source. This helps avoid duplication of effort and ensures that everyone involved is up to date on what's happening. And again, that central source of information can be described in your playbook. And I think it's really vital to do this. This is important, again, especially as you get higher up in severity of the problem you're debugging. If it's having an impact on the customer, there's probably a lot of stakeholders involved beyond just your team, maybe other teams, maybe other business units in your organization, or maybe other companies are involved as well. And so while it's not always possible, and it's definitely one of the most difficult things to do, I know that in many of my debugging sessions, I've actually not been able to follow this best practice. It's something that we should always be aspiring towards and trying to achieve. Because if you have that information as a central source, that makes it so much more easy to communicate and keep up to date with the current state of the world. So given those general debugging best practices, I wanted to talk about the playbook that I specifically use for debugging problems in the networking stack. So the first thing that I always like to do, whether it's trying to debug something that I've encountered on my own or debugging a problem that somebody else has presented to me, is create a problem statement that's agreed upon. This might seem a little bit silly, because if it's a problem you've encountered, you might argue that you should know what the problem is. Or if somebody else is bringing the problem to you, you might say, well, they told me what the problem is. They had to communicate it to me so that I would be able to help them. But more often than not, a problem statement can have many different threads that are interwoven. Somebody might come to you and say, yeah, like, I don't know, like, we're seeing a lot of like IO timeouts for some network requests, and our memory and CPU seems sort of high, and we're also having this increased latency. And while those all might be problems, they're not necessarily to the same order of magnitude important in finding a root cause for or fixing at a given time. And so it's important to tease apart and say, while these three problems might be interconnected and may relate to each other, let's prioritize them. And let's talk about really what the most important thing to debug is first and have that shared understanding. Additionally, I always recommend trying to visualize the problem in terms of network connections, if at all possible. I think this is really beneficial for two reasons. One, not everybody is a native English speaker or a native speaker in whatever language you're interacting or working in. And so by having that visualization, it provides another way to ensure that everyone is on the same page. And secondly, not everybody learns by reading a wall of text. I know I'm more of a visual learner, and so this is why I always bring up the importance of trying to diagram and draw things out so that we can ensure that shared understanding. After we have level set on the problem, the next thing that I do as part of my playbook is level set on the network topology and configuration. So understanding the entirety of the platform and infrastructure setup, not just the bits that are involved with whatever the problem may be. Because again, it might be something further up or further down in the networking stack than what's initially presented. That might be the issue at hand. And again, I really recommend drawing out that topology. And right now, as we are almost all working from home and working remote, I highly recommend Miro as a tool that you can use for collaboration and visualization. It's really nice because not only is it easy to draw and collaborate together on that shared understanding of the network topology and configuration, but it also will create for you an artifact. So even when I did work in person with colleagues and we would be debugging things, I would still sometimes recommend actually using Miro over, the typical drawing on a whiteboard and then taking some like grainy, not high quality photos of that architecture. After you've level set on your network topology and configuration, the third step in the playbook is to gather other additional information. And I realize that this is a super vague statement, and that's because it really depends on your infrastructure and platform. We all come in here wearing different hats. Some of us may be platform operators, some of us may be application developers, and therefore have access to different levels of information. And so this other additional information really does vary based on what you have access to, both in the role you play and also based on what your infrastructure or platform is providing to you in terms of additional information. But to try to make it a little more concrete, you can think of this as things like logs, metrics, memory, CPU utilization, etc. And so then after you've gathered this information, you might think, when can I actually start debugging the problem? And it's finally here. The fourth step is to come up with a hypothesis that can be validated or invalidated and a plan of attack for doing so. And if the first hypothesis you come up with turns out to be not the root cause, then you rinse and repeat on step 4 until a root cause is found. Of course, gathering additional information that may be of importance along the way if need be. So I wanted to finally close out this section by acknowledging that especially when debugging production issues or major problems that might impact customers, there are some common pitfalls that get even the most seasoned of us who debug. And the first one is trying multiple fixes at once. Again, when you're in a situation where there's a customer impact or a major outage, you definitely want to be getting a fix as soon as possible. So I'm not here to tell you that you shouldn't be trying multiple fixes at once, because the end goal really is to first get everything stable again and then figure out the root cause. But if you are trying multiple fixes at once, it's important to understand how each of those fixes can impact each other. And furthermore, because of that, it's really important, again, to be keeping that central source of truth, so you know exactly what's being played out and tested at any given time. The other common pitfall is misalignment on problem statement, strategy, etc., which again, really can be remedied by having that shared source of truth, that shared understanding. And that's why those best debugging practices really are important to keep in the back of your head, even though when somebody says them, you might say, well, duh, because it really can go a long way in helping with your debugging session. So with that, we're now going to sort of zoom in when thinking about the playbook on that step 3 of gathering other additional information and talk about some debugging tools that are specific to debugging networking problems. We're going to talk about 4 tools. They may all be very familiar to you, but it's important to always reacquaint ourselves with tools in our toolkit. And it's my belief that the simplest of tools are the most powerful for debugging. And so the first tool that I wanted to talk about, starting sort of from the very lowest common denominator to back up in terms of power and use, is ping. Right, so ping is a command line utility available on most operating systems. And it makes a request to a destination using Internet Control Message Protocol, or ICMP packets. And ICMP is a protocol that really is supposed to just test the network connectivity and that a destination is reachable. So I think ping is really valuable and is often one of the first tools I use because it allows me to do that initial network connectivity test. You never want to go deep into coming up with many hypotheses for problems that you've encountered in the networking stack, only to later realize that actually the issue was that I had a firewall set up, or I had some IP tables rules that were left over on my machine that has just been like swallowing traffic or default denying it. And so by using ping, really simple, really just straight up front as part of your debugging session, you can rule out network connectivity as an issue and then go down alternate routes. So, you know, doing a little bit extra upfront can sometimes save you in the long run. The next tool I wanted to talk about is netcat, which is also a command line utility available on most operating systems. And with netcat, it allows you as a user to both read from and write to network connections using either TCP or UDP as your protocol. So the way that I most commonly use netcat is either for checking the format of requests. So you can use netcat as a server, you can send a request to it, you can sort of see the payload, see the format. Or you can also use it to check that traffic is able to reach a destination. So on one end, maybe on the machine you're trying to see if it's reachable or not, you can set up netcat as a listen server. On another machine, you can use it to send traffic over, and you can test for connectivity in that way. And you can also use it for port scanning, seeing what ports are in use, what ports are available, and file transfer as well. And so netcat really is, as it's often called, the Swiss Army knife of tools that has a lot of different uses and is very powerful. The third tool we're going to talk about is tcpdump. And tcpdump is honestly my favorite tool. We're going to see it referred to a lot in the debugging common scenarios because it really is what I fall back on and is one of my favorites. tcpdump, of course, is also a command line utility available on most operating systems, and it allows users to capture network traffic. So that's why I really like it and I find it really powerful, is that, I don't have to worry about, a port not being in use. I can just be capturing live traffic as it's happening and then be able to analyze it. So I don't necessarily have to be mucking with my system at all to be capturing powerful information. The one downside of tcpdump, though, is there is no GUI. So it's most useful, in my opinion, for capturing traffic. You can output the contents of tcpdump to a file and then upload that file to another tool to analyze. And this way also you're saving all the information at any given point in time, which is always a best practice. And so given that, our fourth and final tool has to be a way of analyzing the output of tcpdump, right? And so the fourth tool that we'll talk about here is Wireshark. So Wireshark is a program available on most operating systems that provides a GUI that allows you to easily analyze packets. You can analyze packets in real time, or you can analyze the uploaded file, which the latter is what I like to do. Again, especially if you're trying to analyze traffic that's running on a remote server, it's a lot easier to SSH onto that machine, run tcpdump there, transfer the file over, and then analyze it using Wireshark on your local system than it is to, try to somehow be running Wireshark on that remote server. And the nice thing about Wireshark is it allows you to filter and inspect packets. So we'll take a brief look at what Wireshark looks like in terms of its GUI. So here we can see I actually filtered based on a specific network connection. And we can see here that it has timestamp, source and destination IP, the protocol, and then additional information about the packets. So you can see, again, this whole network connection. And this is actually from a debugging session that I've done previously where we were seeing a connection close and reset earlier than we would have expected. So with the introduction to those four common, often used, yet very powerful tools, we'll now talk about some common network failure scenarios and how you might go about debugging them. So the first one I wanted to talk about is a specific network request fails. So in this scenario, you know that a network request is failing and you know what network request that is. The first thing, again, as we think back to the playbook and best debugging practices that I recommend doing, is to understand your network topology. And so we'll follow along with sort of how I would approach this problem with a very simple example. And so if we're understanding our network topology, we'll understand it as a client app talking to a destination application via a load balancer and gateway. Now, given we understand our network topology, the next thing that I would do is SSH onto the machines that are failing. So in this case, let's say we're able to SSH onto the client and destination application. And as I mentioned before, I would just try pinging different addresses, especially if it was like a connection refused or a timeout, just to ensure that there actually is network connectivity that's expected. So I ping local addresses in the private network, public network. I also would validate that DNS is working because the number of times that DNS has actually been the problem is pretty surprising. And then assuming that network connectivity is working, then based on the architecture of the network request path, I would SSH onto the other machines that I have access to that are involved and take a TCP dump to see what's happening at each stage. So, again, thinking back to all of the components involved in this network path, if possible, I would SSH onto each of these components. Of course, that's not always possible, but for the components that you do have access to, SSH onto and take a TCP dump to try to get that full network packet request path and see exactly where the connection is failing. And again, to do that, I would use wireshark to analyze. The next scenario that we commonly see when debugging quote unquote networking problems is a high network latency. So when somebody comes to you and says, I'm seeing an increase in network latency, the first thing I would say after, of course, level setting on the problem statement is to understand your network topology and understand what the expected latency is in this case versus what the current situation is. Are we seeing 10 times increase in network latency, 100 times, 50 times? Are we seeing it across the entire platform or only in a specific set of applications? Understanding that is really important so that we then know what we should do next. If we assume that, again, we have a very simple network setup here of a client talking via load balancer and gateway to a destination application, and assume in this scenario that we're only seeing increased latency for a specific set of applications, this network path included, the next thing I would do is compare the latency of this request path to that of other applications, machines, etc., just to gain an understanding of just how different it is, and then also do a comparison of the configurations to see if there's anything wildly different there. Assuming that you still don't quite have an idea of what the problem is, I would then SSH onto each machine involved and run the same curl command to the destination application, timing each curl to see how long it's taking. So in this case, if we ran time curl to the destination application, this will be really helpful. And even if you can't do this again for every single network hop, maybe you don't have access to the gateway, for example, or have access to the load balancer, doing it for a couple can greatly narrow where the latency may be coming from. So for example, even if you only have the client application or like maybe a different application in the system that takes a different network request path, that can be really helpful in trying to pinpoint and rule out different components as being the source of increased latency. So in this case, saying we time the curl for each of these, from the client app to destination, let's say it took 1500 milliseconds. Looking at these results, we would note that there's still a really high latency from the gateway to the destination. And so that would tell us to really focus in on that connection and that network hop between the gateway and destination. Once you find the machine that's introducing additional latency or that network hop, you can then dive deeper in and start debugging what might be causing that network path to have that additional latency. So you can look for changes to the machine, infrastructure, maybe there's an increase in CPU memory, etc. Next, we'll talk about a favorite, intermittent network failures on the platform. Of course, this is like the most dreaded networking issue. It's intermittent. You probably don't have that much information about it. And so, of course, the first thing, sort of getting old to say, but true, is to understand your network topology. And then to be completely frank, this is really challenging. And the second thing to do is to try to gather as much information as possible. Ideally, you've been storing the history of these intermittent failures somewhere, so you can be looking at it. If not, that's the first thing you'll want to do is start capturing these intermittent failures so you can analyze it later and try to look for patterns. Is it a specific type of request that's causing this intermittent failure? Is it happening at a specific time of day? A specific node? Namespace? What are the commonalities between the applications that are experiencing these failures? Pattern matching can be challenging and definitely isn't always the funnest thing, but when you're tasked with intermittent network failures on the platform, pattern matching really is one of the best things you can do. Because then based on that, you can take TCP dumps of the components that are involved in those intermittent failures. If it's happening frequently enough, hopefully you can capture a request. If not, if you've identified the common pattern, you can try to replicate the problem while taking TCP dumps so that you can then have even more information about what's going on in the system. And so last but not least, I wanted to do a brief aside on TLS. So with TLS, one of the top things I always like to say is you might think you're speaking TLS, but you aren't actually. And so I always recommend to use tcpdump to ensure that your traffic is actually encrypted. You might have checked that box that says TLS is good to go, but sometimes your traffic, for whatever reason, can't be encrypted, and so it falls back to plain text. Because rather than not be able to communicate at all, platforms sometimes decide that's better to be able to communicate insecurely. For example, one of the most common reasons that your traffic can't be encrypted is you've misconfigured certs, and that's really easy to do. So always check that if you think you're talking TLS, that you actually are. And with that, in summary, networking is really hard. And debugging networking problems is just as difficult. It's a really vast landscape. It's really hard to either be general or it's really hard to be general because there's so many different ways that you can go deep into different layers of the networking stack. I hope that if nothing else, you take away that small, simple tools are really powerful for debugging a variety of networking problems, and that you feel equipped to at least have a starting point or an understanding of where to begin when faced with a networking issue. It's important to level set on your architecture and a plan of attack. And so if nothing else, I hope that you have taken that away. So thank you so much. I'm gonna stick around to answer any questions that folks may have. But otherwise, you can also always tweet at me any questions. I don't tweet that often, but I'm more than happy to reply when I see it. And that's it. Thank you again so much. And I'll answer any questions that folks may have in the QA section as well.